Hi again. This is part 2 of your HEC-HMS setup. So we did the easy part. We put in all the information we had from TP 108 into 2 different catchments, draining to a single junction point. So now we're going to do the rainfall, associated rainfall data input. I will share my screen. A moment. Here we go. Okay, so over here on the left, we need to add another component. The next component is the meteorological model. We just call it MET1. And we're using all of the defaults, but we'll change that. Replace missing set to default, we'll just replace that. And yep, cool. We go to precipitation gauges, and we'll call this our 2-year storm. We want to put our total 24-hour depth that we had before. Where was that? One moment. Where did we put that? Our 2-year 24-hour depth was 25 millimeters. So putting that in there. Go back up to the thing. So we're going to include sub-basin 1. Yes. So then you go through and go to that. Basically, you're telling it's a bit of a squishy, unpleasant bit of the model, but you need to tell it to select that gauge, that precipitation gauge or that rainfall gauge that you just input. So you have to put yes. And it says what are the weights, so we just want it to be 1, right? Because basically it's just going to be, 1 times the number, so just the number. Similarly for this one, we want to say yes, we want to use that gauge again with the weights. Now, if your model ever doesn't run, there will be something to do with this part of it. So just be wary of that. We'll close those down. So that, let's rename it to our 2-year storm metric, blah, 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 including sub-basement, yes, use indexing, no, leave it to no. Cool. Now let's add another one, meteorological model, MET2. Let's call it our 10-year storm, create MET2. So same thing. Pick up. 3-storm, 10-year storm, basins. Yes, we want to include. Here we go. So for MET2, 10-year, and the depth for a 10-year storm is 130 millimeters. Cool. Yeah, so that's all there. See how it's easy to make mistakes. So then again, go through here to the pakaranga gauge weights. Oh, make sure we say yes, use that gauge, weight of 1. Same for the pakaranga impervious. Make sure we say yes, use the gauge. We'll give it a weight of 1. Ta-da! And we want to do one more, which is MET3, and we'll call it the 100-year. Okay, and we want to use the sub-basins, yes. We're going to go, and it's the 100-year, and the total depth is 200 mils. Yeah, and then we want to apply it to this one, 1. Again, we want to apply it to this one. Use gauge, yes, weight 1. Cool. So sometimes it loses those connections when it's running. So sometimes you have to go back and make sure everything's linking like that. So that gives us our meteorological models. The next thing we need to do is control specifications. So we open that, control 1. So this is just to tell it how long to run the model for. So we usually do a start date of 01 Jan 2000, just to give it somewhere to start running, and then we end it a day later on the Jan 2000 end time. And usually I think we set this to 1 minute. Yeah. Then everything is under control. That's pretty easy. One more thing to add is the time series data. So let us have a look at that. So that's linking to all of the different stages and basically putting everything together. And this is where we need to look at the spreadsheet that I gave you. So this spreadsheet, I just open that. One moment. Stop sharing this screen, share the other screen, share. So this has been set up for you. So what it does is creates a table showing that it basically creates a hyetograph. A hyetograph, remember, is the spread of the rainfall over the 24-hour period, and it's that graph sort of got a peak in the middle. So what you need to do here is add your 24-hour depth at the top that we've got, so 75, and it spreads it over that time period like that. These numbers in yellow are what you need to copy and paste into your model.